Okay, here we go on to 7.5. I will finish 7.4 with you in class. There were only 2 problems left, so I didn't make another video. We'll just do it in class. 7.5 is several radical terms, and basically you have to think back to when you learned how to add x's, and your teacher said, okay, if I have 5 apples in this hand and 4 apples in this hand, I can combine them and make 9 apples. But if I have 5 oranges in this hand and 4 apples in this hand, I can't combine apples and oranges because those are not like fruit or like terms, x's and y's. Now we're talking about like radicals. Like radicals have the same indices and radicands. So if you look over at my picture, this little root is the index, or plural indices, if there's more than one of them. And the radicand is the number under the radical. So, for example, I have 6 rad 7 plus 4 rad 7. I have like radicals because I have rad 7. They both have an index of 2 because they're square roots, and they have a radicand of 7. So if I have 6 of them plus 4 of them, I now have 10 of them. 10 rad 7. Not too difficult, so you just have to check the index and the radicand. Okay, number 2. Cube root of 2 minus 7x times the cube root of 2 plus 5 times the cube root of 2. I'll move in, oops, a little bit for you. So I have cube root of 2, I have 1 of them. I have minus 7x of them. 1 and 7x are not like terms though. Plus 5 of them. So I know I have 1 plus 5 makes 6 cube root of 2 minus 7x cube root of 2. And this can also be written as 6 minus 7x cube root of 2's, or factoring out that cube root of 2. This is how you'll see it in the book and Math Excel. So you need to factor that out at the end if you can. And I don't think it matters if you put this at the back or the front of the parentheses, though. You'll have to let me know if Math Excel allows that. So let's try number 3. 6 fifth root of 4x's plus 3, oops, that's a big 3, 3 fifth root of 4x's minus the cube root of 4x, no, the fifth root, excuse me, of 4x, minus one of them. Sorry for my mistakes. So I have the fifth root of 4x, the fifth root of 4x, and the fifth root of 4x. So I have 6 of them, plus 3 of them, minus 1 of them. 6 plus 3 is 9, minus 1 is 8, fifth root of 4x. Not too bad. Alright, so now I have the 3 rad 8 minus 5 rad 2. So these have the same indices, or index, because they're both square roots, but the 8 and the 2 aren't the same. That doesn't necessarily mean we're done, because this 8 can be factored. 8 is really 2 times 4, 2 times 2. I hope you're used to factor tree. And there's a pair of 2's. So I have this 3 is out front, one pair of 2's comes out, it leaves one lonely 2 inside, minus 5 rad 2. 3 times 2 is 6 rad 2, minus 5 rad 2. Now I have like radicals. 6 rad 2's minus 5 rad 2 is 1 rad 2. Okay? So let's look at number 5. What about 9 rad 5 minus 4 rad 3? The indexes are the same, but the radicands are not. Can 5 be factored down? No, 5 is prime. Can 3? No. So here they don't have like they're not like radicals, so you just can't simplify. There's nothing else you can do. Just leave it alone, and that's a perfectly fine answer to leave like that. So number 6 says the cube root excuse me. The cube root of 2x to the 6th y to the 4th plus 7 times the cube root of 2y. So write that down. And now we need to look to see if we can factor anything out of here before we check for like radicals. So I need groups of 3. I know 2 does not have a group of 3, so 2 stays in. Does 6 have a group of 3? Yes. How many groups of 3 are in 6? 2 groups of 3. Or you can say 6 divided by 3 is 2, with no leftovers, so there's no lonely x's left inside the radical. How many groups of 3 are in 4? 1 group of 3, so y to the first. You don't need the first written there, but you can. And how many are left over? Well, 4 minus 3 is 1, so it leaves 1 inside as well. Plus, I'm just going to recopy, 7 times cube root of 2y. And now I have like radicals. I've got cube root of 2y and cube root of 2y. So I have, but I can't add x squared y plus 7, but I can factor out these cube root of 2y's. Cube root of 2y times x squared y plus 7. So that's like number 2, example number 2, where we had to factor that out. Okay, so let's look at number 7. Now here, if I multiply, you multiply radicals just like you would distribute and multiply numbers. So here we have square root of 3 times the quantity x minus square root of 5. So I'm just going to distribute. Square root of 3 times x is square root of 3x. Here's where I'm going to make you be really careful. If your square root bar falls over your x and it looks like the x is underneath it, it will be marked wrong. That is different. So I write the x in front and then I never have to worry. Minus square root of 3 times square root of 5, you just multiply, is square root of 15. So I'll accept either answer as long as you're neat for that top answer. Okay? Again, if there's any questions, please come see me. So we're on number 8. We have to give these video notes a chance before we decide if we love or hate them. Okay, so we have cube root of y times the quantity cube root of y squared plus cube root of 2. So again, we're going to distribute. We have cube root, and times a cube root leaves cube root of y to the first times y to the second is y to the third plus the cube root of y times 2 is just 2y. Done. Number 9. 4 rad 3 plus rad 2 times rad 3 minus 5 rad 2. So here we have a binomial, 2 terms times 2 terms, so you should all be saying the magic word is FOIL. So first times first, 4 rad 3 times 3 is 4, rad 3 times rad 3 is 3, so that just makes 12. Outside, 4 times 5 is 20 minus 20. Rad 3 times rad 2 is rad 6. Inside, rad 2 times rad 3 is plus rad 6. Last, rad 2 times 5 rad 2 is minus 5. Rad 2 times rad 2 is 2, which is minus 10. And now negative 20 rad 6 plus 1 rad 6 gives you negative 19 rad 6. So there's your answer. Square root of a plus square root of b times the square root of a minus square root of b. So please let me know, or please go ahead and try this. I would push pause. And so now, if you FOIL, we have square root of a times square root of a makes a. Square root of a times square root of b is minus square root of ab. Inside, square root of b times square root of a is plus square root of ab. And last, square root of b times square root of b is b. Minus ab plus, or minus square root of ab plus square root of ab cancels, and you're left with a minus b. Which leads us to a new term called conjugates. Conjugates are pairs of numbers like a plus b and a minus b. That's a conjugate pair. Up here, these were two things being multiplied by a conjugate pair, and you can see that a nice little answer came out of that. And that will happen. So you need to recognize what conjugate pairs are, because we're going to use them to rationalize denominators with radicals. So if I have 4 over square root of 3 plus x, and I have to rationalize it, again, that means get the radical out of the denominator. So what you have to multiply by is a 1 in disguise, and that 1 is going to be the conjugate pair of the denominator. So if the denominator is square root of 3 plus x, the conjugate is the square root of 3 minus x. And you're going to multiply that on top and bottom. And it doesn't change the front sign. Conjugates only change the sign between the two terms. So here we're multiplying, we're just going to distribute 4 rad 3 minus 4x. And on the denominator we have to FOIL. Rad 3 times rad 3 is 3, minus x rad 3 plus x rad 3, and x times negative x is minus x squared. So we have 4 rad 3 minus 4x over, these canceled, 3 minus x squared. Take a moment, write that down. And here's a problem I want you to try. Come in and show me. And when you show me these, I'll give you your points for this section of notes. So this is 7.5. And again, we have 2 more quick things I'll show you after this, but this is where I'm going to end the video.